Okay, so welcome. Don't worry, I'm not going to dance. They don't pay me enough for that. But I'm going to talk about database as a service. And my name is Jon Jahren. I work in Microsoft as a data platform architect. I have about 20 years experience as a SQL Server technical specialist in different types of roles. I worked in Microsoft for 7 years. Just interrupted by a break, so I had a 5-year break from Microsoft, but I started again this fall. And one of the reasons why was that they had a completely new organization now, and they have this role called architects. So what I do is that I engage with customers in architecture discussions. I deliver proof of concepts, workshops. I do architectural design reviews. I run hackathons and do presentations. But I'm not a consultant. I don't bill hours. I'm not measured on sales in any particular degree. So I just talk about technology. And this is a completely new organization. The focus of this of these types of roles is that Microsoft is moving, as you've seen the last years, transformed from an organization that just protects their OS footprint and their Office footprint and everything, and more focused on solution sales and developing solutions, especially through the cloud transformation. So that's my role, and we have open positions in Norway today, just so I should mention it. So I have 2 sessions today. I'm going to talk about, of course, my favorite product, SQL Server. And my first session now is to talk about running SQL Server as a database as a service environment. And my second talk today, 3 o'clock, is to talk about running SQL Server on VMs as an infrastructure as a service, both in Azure and running it in your own data centers. So, database as a service. So database as a service is, of course, as you know, that you just connect to a database, but you don't care about how it's managed, all the infrastructure stack that supports the database. You only manage a single database and connect to that from your application, and the rest of it is taken care of by someone else. And of course, the SQL Server team has, for at least the past 15 years, since the release of SQL 2000, moved the product in the direction of more and more delivering SQL Server as a service. Of course, there are some products in your network, for example, Active Directory. You don't think about Active Directory as a server. You think of it just as a service that exists in your network. And the previous releases, the SQL Server team has always tried to move the product in that direction, but there are some limitations, of course, to the customer demand for that type of stuff. So when we in SQL 2008 launched the SQL Server Central Management Server infrastructure, so you have a dashboard in your SQL Server Management Studio where you could just manage your whole network as a whole, your SQL Server database as a whole. Very few people use that. So what we found out that it maybe is better to run the SQL Server as a service, the database as a service, on a separate layer in your architecture stack. So that's what we're going to talk about now. So first, I'm going to talk about Azure SQL Database, how you can run your databases on our public cloud, and then give you some insights in the behind the scenes, how we actually run it in our data centers. Some key takeaways of that you could implement in your own data centers, and then talk about how you, in an Azure Pack, Azure Stack environment, when you run your Azure infrastructure locally, how that works, and ideas there also to take away if you want to run database as a service in your own data centers. Okay, first of all, the SQL Server product team now, when the SQL Server product team started to started to offer this Azure SQL database, it wasn't like we just hired the double amount of developers and said that this team is now working on Azure SQL and this team is now working on on-premises SQL Server. What we actually did is that we moved most of the developers into the Azure SQL Database team. And we decided that Azure SQL Database should be the proving ground for all new features in SQL Server. So we build for Azure, we roll out new features in Azure SQL Database first, and then we have these 24-month, 36-month intervals where we take the new features that have been released in Azure lately and then package it for an on-premises deployment. So we have a very complicated build environment, but we still have only one product team. So this means that a lot of new features that are coming in SQL Server 2016 this spring or summer, late spring, is actually technology that actually is in release in the cloud today. So when people start talking about, yeah, but we can't use new features in SQL 2016. First, we have to wait until it's matured for a year or something. A lot of people forget that these features, these products, have already been used by millions of databases, because there actually exists millions of Azure SQL databases today that actually run these features today. So that's an important part of it. So the product now is that the product team develops for on-premises SQL Server, on-premises SQL Server Appliance, which is the APS. The SQL team works for optimizing Azure SQL virtual machines, the Azure SQL Database, and the Azure SQL Data Warehouse, which is a product now in preview, but will be released in the next months. So what does it mean when we build a platform as a service offering? So as I said, the Azure SQL Database runs actually on the latest builds of SQL Server. It runs, the Azure SQL databases are just ordinary databases running on ordinary SQL servers on the latest code base of the product. And it runs on top of basically what you locally would deploy as clusters with availability groups built in. But in Azure, we scaled it up a considerable degree, where we, instead of clusters, we use the Azure Service Fabric, which is a set of microservices in Azure that support stuff like messaging, eventing, health detection, health monitoring, orchestration and lifecycle management of software releases and everything like that. And this service fabric is kind of the equivalent to the Windows failover cluster service, just that it is much more. So we're actually running, when you deploy your Azure SQL database, we create a database on a SQL server that runs in a service fabric cluster of about 140 to 150 SQL servers. And we generate 3 copies of your database across 3 SQL Server instances in the service fabric, and where 2 of those are failover replicas. So we actually create your database in an availability group, just as we can on premises. I'll get back to it, how it actually works. And then we have 2 replicas, so for failover purposes. That's why when you create an Azure SQL database, we guarantee, or our SLA says that it has 99.99% availability, while separate SQL Server running on a single Azure VM only has 99.95% availability. So, because of the replicas. If you in Azure designed, instead of using an Azure SQL database, instead created a VM in Azure, ran SQL Server on that, created an availability group with 2 replicas, and just put 1 database in the VM, you would actually design the exact same infrastructure or equivalent infrastructure as we do when we spin up Azure SQL database. So it's not just a decades-old server running on a VM. It's a very complex infrastructure. And we have several millions of these Azure SQL databases running in production in Azure today. So when you created a SQL Server Azure SQL database, The first service tiers that we released were the basic and standard, because we first wanted to address the low-hanging fruits, the databases that were not like the most heavily transaction-intensive databases, but the ordinary business applications. And then for a year ago or something, we released the premium service tier, which had much higher throughput for the massively heavily transacted databases. The premium product, premium database service, gets a lot of that extra performance from our Gen 4 data centers, the G series VMs that you can order also on Azure as single Azure VMs, and through the use of SSD storage, the premium storage. But all these database service tiers are built on the same service fabric, and all of them have an SLA of 99.99% availability. So the latest version is what we call Azure V12. That is the version of Azure SQL Database that is in production today. It is actually the SQL 2016 code base that is running, and similar to the CTP3 that is out now on the SQL 2016. Of course, since it's kind of mapped to the SQL 2016 CTP3 released, and the CTP3 isn't completely feature complete as it will be in release later this spring. But so there are some features that are not there. And also, of course, there are some features in the product that don't really make any sense in an Azure environment. So you will never see complete parity between the on-premises product and the Azure product. For example, there are some system tables and dynamic management views that don't make any sense in Azure, but only make sense in on-premises, where you have access to the OS resources, for example. So it will never be completely parity on all the functions and metadata tables and everything, but pretty much the same. So it runs on the Generation 4 hardware in Azure. Now, we usually don't go into detail about what kind of hardware resources we actually use in our data centers, but the Generation 4 hardware is hardware that we actually build ourselves. So since Microsoft is an original device manufacturer, of course we build mouses and keyboards and computers, and we build Xboxes and everything. The same factories also build the Generation 4 hardware that we run in our data centers. And these hardware is are designed as you can think of it as blades, but they have very high density, so a lot of servers in one box, and they're also designed for not so much cooling as we used to do on the Gen 2 and Gen 3 hardware. So the whole idea is that instead of spending a huge amount of resources in trying to keep your servers cool, we just in Generation 4 said that forget it, let's just ventilate it and let all the warmth, all the heat from the servers just let it out into the into the atmosphere, and just the same as you would actually the same thinking as we do here in Norway when we have cold winter homes. Instead of trying to keep your temperature always at the same level at like 24 degrees inside your house, why can't we just put some more clothes on and just let it be cold in the same sense? So the Generation 4 hardware is designed to be cost optimized and have less focus on cooling and more on just ventilation, natural ventilation. Of course, these servers will never be sold as a commercial product. We only build them for internal purposes, and it makes a lot of sense when you need to deploy literally millions of servers in our environment. Just the cost savings of managing to build a server that is just $20 or $50 cheaper than you could buy from any other place. It amounts to a lot of money when you build huge data centers. Okay, so the latest Azure SQL Databases, when you provision an Azure SQL Database today, you let's see here, I'm in the Azure portal. If anyone, some of you may never have done this before, but you have here the platform as a service apps. You have the SQL database. You have some new stuff here that will be released in the next month, Data Lake, SQL Data Warehouse, and so forth. But it's the SQL database that is important for us. And here the database needs, of course, to have a name. Let's just call it demo Jon 4 or something. You can start from a blank database or start with a backup of a database that you are deploying. And we have Visual Studio integration here, so you can take a DAC pack or backpack that you deploy from a Visual Studio project and start as a template here. And here are the pricing tiers. And the premium ones use SSD storage, and the standard uses traditional storage. And the P11 is the highest scale, and it supports up to 1 terabyte databases, and costs 50,000 crowns a month. But it's actually, you have to compare it to what you would get if you ordered a Azure SQL VM with the same amount of resources, deployed 2 additional VMs as replicas, and designed that type of environment. Okay, as you see here, I'm of course logged in my Microsoft tenant here. I am so it's an internal subscription, but you will see the same stuff when you log on to your Azure portal. Okay, these performance levels for the platform as a service environment, we don't really talk about the amount of CPU and memory resources that each Azure SQL database is set at. Instead, we measure them in database throughput units, DTUs, which corresponds to the amount of performance that you get on each tier. And we support individual scaling, so that if you are not satisfied with your P4 subscription, for example, you can scale up to P6, and the database remains online while we add those resources. And I'll soon tell you actually how we do this. And since it's hourly billed, it's cost efficient because clients can then just stop the database if they're not using it anymore, and you just pay for the amount of storage, or the storage included, of course. So the DTU, a lot of questions ask us about what is the actual DTU. And since we're offering a cloud-based database, it doesn't really make any sense to talk about CPUs and everything, because we want to continuously improve our hardware infrastructure, moved from generation 4 to generation 5 and 6 and so forth, without that reflecting the amount of pricing level that we offer our service tiers on. So the DTU is actually a bounding box constrained by some compute, like a level of relative compute power, some a memory constriction, and some reads and writes constrictions that we want to bound the DTU thresholds inside. And then we, as the database actually runs, the workload runs, it is monitored, and the performance is capped to the DTU level that the service is at. So DTU represents the amount of resources that is assigned to the database, and is an abstraction from the underlying hardware. And we actually use resource governor. So since these are normal SQL Server that actually run these databases, the component in SQL Server that does this, and you can also do it yourself in any SQL Server, is to use resource governor to enforce those same constraints. So DTU represents the power of the database engine, and it's defined by the bounding box with the different resources. And it's used to compare the power of the different offerings, and also to give some kind of predictability in the amount of scale that you receive when you go from 100 to 200 to 500 and so forth. So you should be able to measure your performance as your performance should double as you double your DTUs. So the dimensions that were targets for when we went for general availability, but this is just unofficial, so these are subject to change, is that, but the P1, which is like 100 database throughput units, was mapped to one core, 8 gigabytes of memory, and one disk unit of data I/O, which is basically mapped to 500 IOPs. So, and for the smaller ones, there's just a fraction of one core and one disk performance. And for the larger ones, there are just increments of several cores and so forth. So when you move from 100 to 200 DTUs, you double the cores, you double the dimensions of the bounding box. Okay? And actually, in order to, but what actually happens now when we move to new hardware and so forth is that in order to stay at the same DTUs, we actually use an internal benchmark. So we developed a benchmark application, a benchmark database and a benchmark application that measures the amount of DTUs that a certain database will receive. And this benchmark is kind of think of it like the, some of you may have seen the TPC benchmarks. There are some industry standard benchmarks for measuring the performance of a database. Transaction Processing Council, there's a website where you can go and check, download a benchmark, run it on a database, and it's like weightlifting for your database. So it will get you a number of how fast your database is. Now the interesting thing is that we actually ran this benchmark on our competitors' offerings also, because we just went to a couple of our competitors, ran the same benchmarks on those servers to see how we compare to those. Because we also want to be cost competitive in order for our competitor offerings and have even better value. And the interesting thing is that one of the competitors, I'm not going to name names here, but one of them, we saw that they have really difficulty doing core slicing between cores, because we saw that they have a lot of parallelism issues. And another competitor, we saw that their offerings on the lower tiers were pretty good, but the scale was not linearly. So when they went to the double amount of price and the triple amount of price and everything, we saw that the scaling didn't really scale linearly. But in our offering, you could have a pretty good prediction of what your performance it will be when you double the amount of DTUs. So this is was a very, very important part of the Azure SQL Database product. The last year, we also implemented something called the Elastic Database Pool. Now, when you look at these pricing tiers, reload. When you look at these pricing tiers, 100 to 200 and so forth DTUs, these pricing tiers are actually fractions of a VM. Since our Azure SQL databases are actually built on top of normal SQL servers on normal Azure VMs, you can get all these are defined in the context of one VM, and the largest VM size is 32 cores. So when you scale up your databases, you can scale up, and the largest scale is actually one whole VM. So you're just using a whole VM. And what we also saw that what if the customer actually has several databases, they can then opt to run all these databases in the context of the same VM, and these databases may have a lot of variable usage of that VM. And in order to be more cost effective, we then the typical scenario here is this software as a service vendor. For example, a software as a service vendor is Office 365. So if or Salesforce.com or some kind of software as a service vendor like that, they could decide to just deploy one database for each customer that is created in their system. And all these customer databases will be created inside the same Elastic pool, and they can all have access to the maximum amount of resources for that pool, but at any given time they could only use a fraction of it. Okay? So it's like instead of having one bounding box for each database, you can have a bounding box for the pool, and inside the pool, every database can access all the resources. And so this is a cost-effective solution for when you have a group of databases with varying usage patterns. But it's not only for software as a service vendors, because we don't discriminate vendors when they sign up for the system. If you have that kind of, or if you have a customer who has that kind of application pattern, it would be a very sensible thing to do. And in an elastic pool, you just pay for the pool, and you can create databases, any amount of databases that you want inside that pool, because you just pay for the pool bounding box. It can also give an elastic pool gives you also some interesting scenarios, because you can also do a cross-database query, because a lot of those software as a service customers, they will want to query across all the databases in their environment, and we support that, elastic queries. And you can also target jobs that work with the elastic pool, and we also have this thing called data-dependent routing, where you can have one database in the pool that has information about which of the databases that a customer connects to. So a customer could connect to a cloud service that checks a central common database for information on which database that has the individual information for that customer. So you could have some reference common data in one database, and you run elastic queries along the others in the pool. So this is something that actually gives you sharding capabilities within the Elastic database. We also, in Azure SQL Database, have an engine that gives you insights into the workload, that it uses machine learning technology and service telemetry to give recommendations to the customers to how better to optimize their workloads. For example, have a better index design and so forth with your databases. Because of course, these databases are just like any other databases that you create in a SQL Server. They still need good indexes, good logical database design. They have to be optimized just as any other database. Just that it's the only difference between this and an infrastructure as a service is that we manage your instances. So it's very important to give customers feedback in what's actually wrong with the databases, and we can tell them a lot of stuff. For example, hey, you should use column store indexes instead, because we see that your workload would benefit from that. In the latest versions of Azure SQL Database, we've added some interesting stuff that I want just to highlight before we move on to the on-premises offering. We now have full support for Azure Active Directory, so you can use your Office 365 identities as security as logins in your SQL Server. We have now full support for the important SQL 2016 table type, which is a temporal tables, where you can have you can flag a table as a temporal, and that table, for every data modification, the table will maintain a history table that has all the changes that have happened. And we then support temporal queries, where you can travel in time and show the state of that table at any given historical time. So you can see, give me the result of this query as it was Friday last week, and not just a current state. So that's a very important addition. We give a query performance insights, which is actually mapped to a SQL 2016 feature, which is called the query store. So in 2016, you will have all your queries can be logged to a special virtual database. And we give a lot of more query insights, for example, with the live query statistics, where you can see your query plans execute while they change while they execute, and you can see them happen. So a lot of this stuff has gone into the product, which was earlier this fall. And then the last things that were added to Azure SQL Database was always encrypted, which is an addition to the ADO.NET provider and SQL Server, which encrypts the data traffic and the parameters for your queries and your result sets that travel between your client and SQL Server, which is important for some customers, because the client can be on an unsecure connection, but the data in your database can be highly sensitive. So without actually having a like VPN encryption or anything, we can encrypt the actual results at the sensitive data. We also offer the full encryption of the database with Azure Key Vault. So this is actually a very good solution in Norway for example, sensitive information. That if you have customers with sensitive information, and you can still use Azure SQL Database, because in Norway we have regulatory demands that says that you can still use Azure for your sensitive information. Just data has to be encrypted. And then there are, of course, different interpretation of that, what that actually means in the Norwegian public sector, for example, health sector and everything. But for the most paranoid, they say that, oh, everything has to be encrypted. All the data has to be masked when you actually access it. It has to be encrypted in flight. The database has to be encrypted. The storage has to be encrypted and everything. And now we can say that, hey, we support all that. So you can do that. And then for performance, we now support column store indexes, which is incredibly important in SQL Server. And since we released column store indexes in 2012 and improved them dramatically in 2014, column store is now the standard for a lot of tables. For example, for data warehousing, we say that now, today, we say that every table you have in a data warehouse should be column store indexed, because it's the most efficient for both the combination of space utilization and because it's compressed, and it's the most best solution also for performance and manageability and everything. So especially for Azure SQL Database, which has size limitations, it's a very, very important feature. And it's supported both for standard and basic environments. So in a normal SQL Server, it's like an enterprise edition feature. But since it's available already on the standard pricing tier, and basic pricing tier, it's a very important addition. Okay, let's move on. So what if you want to run this on premises? Now there's been a lot of talk lately about the Azure Stack. Now for the past 2 years, we've been offering something called the Azure Pack. And the Azure Pack is like a subset of the Azure functionality that you can run if you're a service provider. You could run it for your customers locally. And we also support, Azure Stack is actually Azure version next, Azure Pack version next. So there's been quarterly updates of the Azure Pack with new feature releases, especially for SQL Server Databases service for the past years. And now we're just saying that, hey, we need to rewrite the whole thing because we want to have better parity to what actually happens in Azure, in your local Azure Stack. So the Azure Stack is a full implementation of the core components of Azure. So you can run run for your customers if you're a service provider. You can run, for example, database as a service using the same portal, using the same DevOps tools with the REST APIs and everything, using the same Azure Resource Manager that we use in Azure, and use an infrastructure that we have some hardware guidance for, but which is you can easily build infrastructure for it. And the core component there in Azure Stack is the same that was in Azure Pack. The only difference with Azure Stack is that we have this full Azure Resource Manager implementation and a lot of the inner workings of how it actually works. So in so there's a resource provider for SQL Server there, which is the same in Azure Stack as it was in Azure Pack. And the role of the resource provider in Azure Stack is to be like an agent that takes, for example, so a user comes in and he says that, okay, give me a database. I want that. I have this subscription that gives me this pricing tier, just as we do in Azure. I want this service tier for this size. I want this edition of your database and everything. And then the service provider logs in the SQL Server instance as, of course, someone who has the permissions to create databases and create availability groups and everything. That's not a permission that we give normal users. So it runs in the security context of a sysadmin in SQL Server. And the resource provider then creates the database, sets the resource governance limitations, just as you do in Azure, and also may create availability group, do a backup restore to the replicas that you have in your availability group, and do all that stuff for you. And so it's an incredible benefit for example, a developer who sits in Visual Studio and wants to deploy an application to your database service, to be able to do that without having any permissions on the SQL Server that could compromise security. If you just gave any developer or sysadmin permissions, hell would break loose, you know. So the core idea to implement database as a service using Azure Stack is that you need first to design a SQL fabric, which the only practical way to do this is to set up a SQL Server, of course, an environment with SQL servers. This ideally should be designed using availability groups, where so in availability group, I'll actually show more of that in my later session today for the where we talk about virtualization. But basically, you set up a set of Windows servers in a Windows failover cluster. So we need to all these Windows servers need to be a member of the same failover cluster. But they don't need any resource groups or failover cluster resources configured. They just need to be members of the same failover cluster. And in this failover cluster, you install on each node at least one non-clustered SQL Server instance. So it's not clustered, just a single SQL Server instance on each of these servers. And then you design availability groups that your databases will be deployed to. And then you will have an environment that looks like this. Just you have your databases, but these databases, here I have a database. This is actually always-on availability group that was created using the always-on template on an Azure VM, and I'll show this later today in the other demo. So here you have your databases that are in an availability group. And I have here one replica. So I have two SQL servers that are just single SQL Server non-clustered instances in the same cluster. And I create databases. And this database here is has the primary on one of the servers and the secondary on the other. And I've configured it as automatic. So in an disaster scenario, it will fail over to the others. And so you designed some kind of environment like this. I'll get back to it later today as your SQL fabric. And then in Windows Azure Pack or Windows Azure Stack, which will be called, from WAP to WAS. And then you create your server groups that will be mapped to the type of service tiers that you have, which you put your instances inside. And then you create your plans and additions, just as we have our database plans like P1, P2, P3, and everything. You will create your plans and additions and subscriptions, and then the tenant will subscribe to a plan. For example, you can get 10 databases for this type of amount, and then you can buy additional packages of 5 databases, and the databases will have this kind of so and so many CPU resources, or you can create your database DTU type of thresholds or barriers if you want to. And then you create a template for applying these in your Azure portal, so the user can actually apply some parameters when they configure this. So the whole point is that when you design your database, you could have your user configurable drop-down boxes here, which set, for example, let's say you want some internal billing of your databases. Some people of you may work in a large organization where each department consumes resources from the others, and you have a cost allocation model where you have some internal billing to cost centers or something like that. Some of you may work in an organization that does that. For example, in Microsoft, in my organization, if I need something from another department, I need to tell them which cost center it's billed to, because we have this internal billing cost allocation model. And this could be like one part of the tenant template that you need to apply to. So typically you will design your database service tiers around the type of scenarios and the type of application spectrum that your customers will be using, your clients will be using. You will design some database service tiers that this is just how we did it, but you could do it somewhere else. You don't need to support 99.99% availability. You could use non-availability groups, SQL Server instances in this, of course, just to accept downtime. So anything goes here. And then you could also, but you would then have the benefit of using that full Azure stack, for example, for identity purposes, so that users could log on to your databases, even when you're running Azure Stack on premises using Azure AD synchronized identities using ADFS or whatever. So your Azure Stack plans to your clients could be, for example, some base offer, add-on offers that the tenants subscribe to, and then you could synchronize this Azure Stack through your billing system and have some automatic billing through this. So for SQL Server, in this type of environment, to support this kind of database as a service, we recommend the use of availability groups as a container for server instances. Although we still support SQL Server failover clusters, we actually see today that most customers don't deploy new failover clusters, at least not on SQL Server 2014, because it's probably a better idea to just keep your existing failover clusters for backwards compatibility. Maybe you have some, you probably have a lot of databases that still aren't supported on SQL 2014, but they still want to run this on the same environment. And or maybe you have some databases that by some other reasons you don't want to run any availability group. So, but the typical customer environment is to still use the same failover clusters. So, if you, for example, have a 3-node SQL Server a Windows cluster, you could run an availability group on a couple of nodes, and you can run a failover cluster on a couple of other SQL Server failover cluster instance on a couple of other nodes, but it could be in the same context of the same Windows failover cluster, so you have everything just managed on one single place. Another key reason to why customers typically run this on on a dedicated SQL Server server farm is for license optimization, since typically, SQL servers have a different workload characteristic than most other servers. SQL Server also has some licensing features that says that if you license all your physical cores with Enterprise Edition, you could add a unlimited amount of VMs with SQL Server instances on top of this, and you only pay for the amount of physical cores on the server. Well, if you decide to license the virtual cores that each VM sees, you have to pay for each of those VMs, even though it could eventually amount to more cores that you paid for than are physically on the server. So since because of this licensing feature, we see that a lot of customers, they actually take their existing VM or VMware or Hyper-V environment, and they slice it and dedicate a set of a VM cluster for their SQL Server environments, both for licensing purposes and for the ability to tune those VM workloads for SQL Server purposes. And I'll get back to that in my session later today, how we actually should do that. So in any practical sense, we typically see that customers deploy dedicated SQL Server always-on clusters on a separate set of servers, and this is typically separated from other servers in their environment. So, and this could also be, it could be a separate Azure Stack environment, although I don't expect to see a lot of that, but there's an Azure Stack is just a simple infrastructure requirement on top of SQL Servers here, and you could easily just design your database as a service just as a separate service farm just for that. Now, I mentioned that when we design our Azure SQL Databases bounding boxes and through the DTUs, we use Resource Governor. And the Resource Governor is also something that you could use. You don't need to use it in if you want to develop your own database as a service environment through Azure Stack. But it's typically something that it will be very handy and a recommended practice. So the Resource Governor is something that we let's see, I can just show it to you here. So it's something that is by default is disabled in SQL Server, but you can enable it. And what happens is that In SQL Server, by default, all connections to SQL Server, when you connect to SQL Server, you get allocated a thread, which has an ID, it's your SPID, and that thread will share resources with all other SPIDs. So everyone by default exists in the same memory pool with the same access to all the resources that your instance sees. So what happens is that you can then define your own resource pools, and these resource pools, come on, these resource pools need to be able to. First, we need to be able to filter what databases or which applications, which users are mapped to this here. So you need a resource classifier function. This classifier function will be activated for each time a new user accesses SQL Server. Each time a connection is established to SQL Server, this classify function will fire, and it will be able to access properties by that connection. For example, which database are you trying to access? Which login are you? Who are you? Which application are you connecting from? And this function will then map you to a specific resource pool if it exists. So this classifier function needs to be written, and it needs to be customized. And it's not, so it needs to be a little bit of script that you need to write. And there's a lot of documentation in MSDN that shows examples of how this should how this should look for different types of scenarios. So you need to have a classifier function that exists that you can just point to here. And then you can then define your resource pools by the CPU limitations, the memory limitations, and some priorities, degree of parallelism, and so forth. And then you can also use IOPs, but IOPs isn't in the user interface here. In order to map to IOPs, you need to. It's actually only available through the stored procedure if you want to configure this through stored procedures. The addition of the IOPS limitation was something we added in SQL 2014 because that's a natural. That was something that we needed in our Azure SQL databases, and it was natural to build it into the product. So when you add the IOPS limitation, you need to you set an absolute IOPS value. So you need to first of all, you should benchmark your system so you know the IOPS capabilities of your server. Okay, and you should target the amount of sequential 64K read IOPS that you get. For example, if you benchmark it through the SQL IO tool, which is a IO benchmarking tool that you can download from free from us, which will show you, if you run it on your data volumes, it will show you the exact amount of IOPS that you get for a given workload. So SQL IO will be configurable with what kind of IO segments do you want? 8K, 32K, 64K. But most SQL Server access for index read is 64K sequential reads. So you should target that as the test parameter, and then you should specify the amount of IOPS that each resource pool will be able to access. So this is something that you can use without regards to if you're using Azure Stack or anything else, but just in order to implement the same type of patterns to your existing SQL Server instances if you have a lot of databases that are competing with the same resources on the same SQL Server instance. And to avoid the noisy neighbor syndrome, which we all are familiar with, where one tenant can consume all the resources as everyone has one neighbor like that, or maybe you are that neighbor, I don't know, but someone who takes a little bit more space and is a bit more noisy than the others. Okay, so this is very useful in Azure Stack environment, where the resource pool is mapped to additions in the Azure. So does it require System Center? System Center is typically, and for Azure Stack and Azure Pack, what we recommend for automation, monitoring, and so forth. But for a simple database as a service, if you're just running Azure Stack for your for a database as a service, all you need is actually the Windows Azure Pack or Azure Stack and SQL Server. They don't have to have System Center. Okay. As you guess, I don't work for the System Center group. I just work for the SQL Server group. So there's some other guy in Microsoft could have a different opinion than me. So which versions of SQL are supported? Now, as I started with saying, Azure SQL Databases are running on the existing. We only have one version of that, and the latest V12 version is the SQL 2016 code base. When you run your Azure Stack and want to support, you do the same thing. You have to decide what versions of SQL Server that are supported, and you can support several versions at the same time. But it's not like you will have a complete replica of what we do in Azure. You have to decide yourself what kind of model you want to do around this, and then of course you need to. If you are a service provider, these offerings need to be done under a license agreement with us, and of course you have to pay us licenses when you sell a license to your customer and everything. So everything of this has to be managed in some kind of way. But the SQL 2012 is the minimum requirement for high availability because availability groups were first available in 2012. And then 2014 is the minimum requirement for resource governor because IOPs limitations was first released in SQL 2014. And of course SQL 2016 will be available when it's available. At this moment we don't have an exact date for the launch of SQL 2016. Some people say May, someone are skeptical to that, maybe later, but we hope to be at least releasing SQL 2016 before summer. And then maybe the general availability will be in some time frame after the release. Okay. So when you run Azure Stack, what is the allocation algorithm? Let's say you have the picture I had earlier. We have an availability group over 3 nodes. You start allocating databases through your Azure Stack SQL database as a service. Now the SQL Server will then the SQL Server resource provider will place your databases on a server that supports the requested edition, has enough capacity, and will fill one server before it's allocated to a new server. So it will start filling up one server and then moving on to the next one. Of course, there was a discussion about, okay, but couldn't we instead do like a round robin, take this first one database there and then one there and one there and then go back and everything. But we decided to do this for have a better predictability and so forth. And but if you still use Resource Governor to bound the boxes that each database accesses, you will still have pretty predictable performance anyway. So and of course, for license planning and everything, I think this is a solution that works fine. But Resource Governor will spread it evenly and predictable, and all databases in the same subscription will be kept on the same server. Just like in when you use the Azure SQL database, it's disappeared here, the parameters, but your databases are made on the same server as your previous Azure SQL database did, in order to in the same subscription, in order for us to have some better manageability around it. So you can use Operations Manager to monitor your SQL Server Fabric in this kind of environment. You can also use, there's also an Azure Pack management pack for your System Center Operations Manager. You can also, it will be upgraded to a full Azure Stack management pack. And you can also use SQL Server agent management tools in this environment. It's just ordinary SQL servers that are running in this yeah. So you can automate it using PowerShell. You can also use, of course, since you will have a full PowerShell DevOps API in your Azure Stack, in addition to your SQL Server. So if you want to automate it by, for example, automatic provisioning your SQL servers through in your Azure Stack, it can be done also. So someone else said, what about if we also want to have support Oracle or some other database in this environment? Well, out of the box, we come with SQL Server and MySQL resource providers. It's kind of fun that we have this full, if you, in internal Microsoft conferences now, it's like, yeah, we need to sell more Linux, we need to sell more MySQL. It would never happen for like 10 years ago. But today we have a strategy that we want to support as many Linux and MySQL if you run it. We would rather you run it with us than anybody else. But as of now, we don't have support for anyone else. But it could be that custom resource providers will be released by partners. So it could be that if Oracle themselves wanted to release like some kind of resource provider for Azure Stack, it would be totally fine for us if they did it. Could be that I'm not aware of everything that happens internally. So it could be that they're actually in the process with it. I don't know. But as of now, it's not our business to support other database vendors. That would be up to someone else to implement. Okay, Azure Pack now. If you are running Azure Pack, we're looking into running that now. It will be supported and enhanced through 2016-17, extended support 2022. Or else the Azure Stack is the thing now. And Azure Stack went into technical preview, so you could last Friday, for a week ago, you could start downloading the Azure Stack. So we would recommend you do that now instead of looking at Azure Pack. But for the SQL Server Database as a service perspective, it's basically the same. Okay, so Azure Pack, Azure Stack could be used to provide database as a service just as we do in Azure SQL Database. We can create different editions, integrate with SQL Server, support with SQL Server features. Okay, that was probably... let's open for some questions. Do I have any questions? Come on. I hope everyone is back for my session later today. I know it's the last session for the day, and a lot of people maybe want to go get home or whatever, but I promise it will be worth your time. It will be the best presentation ever. Okay? No questions? Okay, you can ask me questions I'll be here all day. So just, yeah, say if you have any questions. Okay, thank you.